Assalamualaikum and hi to all my panels. Today, I would like to present my final year project 2. My project title is a motion control of rotational crane robot using Arduino. My name is Muhammad Hasrul Fitri bin Ahmad and my metric number is 2018227104. My project is under supervision of Prof. Dr. Muhammad Azmi Ayub and my co-supervisor is Dr. Muhammad Hanif Ramli. There are 8 highlights in this presentation, which are intro, problem statement, research objective, scope of work, literature review, methodology, result and discussion, and finally, conclusion. Okay, firstly, we go to the introduction. Motion control of rotational crane robot using Arduino was a continuation of previous research on development of control system for inverted pendulum. The term of gantry robot represented by a full-rota pendulum that is an inverted pendulum concept that pivots around the end of a main arm that is driven by DC motor and data recorded by encoder. The main purpose of motion control of a gantry robot is to move a load as fast as possible without causing any excessive sway at the final position. This research designed a new control method that eliminated the sway angle of the gantry robot. The requirement of accurate and final load position requires the trajectory planning of a gantry robot that can eliminate residual sway of the load. Thus, this research addressed some of the issues in developing a new control method of the gantry robot using Arduino. The figure below was the 3D drawing by the previous research that showed the overall component of the Frota panel system. We can see that the system is include of Arduino board, DC motor, link arm, encoder, and PWM. Next is problem statement. Statement number 1 is move the system from one place to another without causing a residual vibration as the system have a vibration when it move to other place. Number 2 is eliminate the sway angle using only one parameters in the PID control system, which is proportional gain constant Kp value with the constant rotational angle. Number 2 is complete the research by doing simulation using Arduino software. Then is a research objective. The research objective number 1 is study and model the control of gantry robot motion. Number 2 is formulate and program control algorithm using Arduino microcontroller. Then evaluate the performance of the robot. Next is a scope of work for my project. Number 1 is this research was restricted to the control and vibration area that related with rotational inverted pendulum. Number 2 is the research was conducted to define the possible way to eliminate residual vibration or sway angle when the movement of pendulum from one place to another by simulation that formulate and program control algorithm using Arduino microcontroller. The final one is eliminate the sway angle using only one parameters in the PID control system, which is proportional gain constant Kp value with the constant rotational angle. Next, I would like to explain my literature review. Number 1 is a motion control system. Motion control system is the go-to controller, a robust, unified control that could be placed into a secure enclosure and have everything attached to it. The source of finding is from the article of Fundamental of Motion Control by Jeff Kearns, March 16, 2018. Number 2 is position control system. Position control system is the controlling equation of the proposed device are derived and rewritten as transfer function to design a robust controller in order to achieve this control goal. This element from two sources that stated in the table. Next is transfer function of DC motor and control system. This element describes the system inputs and output behavior. These findings are from the article of Transfer Function Modeling, a literature survey. December 2015, and the role of transfer function in the study of stability analysis of feedback control system with delay, January 2019. The PID control system is get The PID control element is get from two articles which are PID controller optimized by genetic algorithm for direct drive servo motor to 25 September 2018 and incremental encoder in electrical drive modeling and simulation October 2010. Next is input shaping. It is a basic way of minimizing residual vibration as lightly dampened devices are placed that get from input shaping for vibration pre-positioning of a flexible system, January 2001 by Azmi Yusuf. The incremental encoder was integrated into the simulation structure of induction motor based drive control system in order to provide the position of the motor shaft. The source is a look into the rotary encoder types absolute and incremental, April 28, 2020. The next element is DC motor. DC motor is an electromechanism by the principle through which the motor operates. Meanwhile, pulse width modulation, which is PWM speed control, as the name implies, works by driving the motor with a series of on and off pulse and altering the duty cycle. Both of these elements get from the official publisher. The final element is the PID, which is proportional integral derivatives control algorithm, is the equation that included in this research. This finding is get from the Understanding PID Control and Loop Turning Fundamentals by Vance van Doren 26 July 2016. Now I would like to present my methodology. Based on the flowchart, the coding was created and run the simulation by using Arduino software. Then developing the simulation and hardware installation circuit using the online software. From the simulation on the Arduino software, the data was recorded and plotted on the graph using Excel. The research was the recorded data of the pulse with a different value of Kp. The simulation was run until the sway angle been eliminated by using the try and error technique, which changed the value of Kp. After all, the data was recorded and plotted in the graph. The final documentation was made to summarize all the findings along the FYP2 session. As you can see on the slide, the first equation is the control signal of adding three terms. Then the Laplace transform of equation is used to find the transfer function of PID controller. The variable Kp is proportional gain constant, Ki is integral gain constant, and Kd is a differential gain constant. The equation number 3 is the calculation of the set point. The figure on the left was the coding that wrote in the Arduino software. The coding was compiled and uploaded in the Arduino Uno R3 hardware to run the simulation. Meanwhile, the right figure was the data and curve that came from the simulation. The recorded data then was plotted to the graph of the DC motor impulse. The result was obtained from the simulation by implementing the new program algorithm using Arduino software. The data with a different value of Kp was recorded in the table and the graph was plotted based on it. The research implemented the effect of a different value of Kp towards the sway angle without change the other PID variables, which are integral and differential gain constant. The set point was represented as the angle that the system moved. Thus, this research set up the set point at 100 pulse, which was converted to degree about 70 degree. Okay, for the graph Kp1 and Kp1.5, we can see that the movement of the system is slow. Then, for the graph of Kp2 and Kp2.5, the movement of the system getting better. Then the graph of Kp3 showed that the system moved fast but have a little sway angle. But for the Kp3.5, the movement of the system is fast and the sway angle was eliminated fastly. Kp4 showed that the system moved fast with a huge sway angle. The last graph was the summarized graph for the all Kp values. and we can see that the good Kp value that suits the system is Kp 3.5, as it can transfer the load faster without huge sway angle. The table showed the effect. The table showed the effect of parameter from the PID control, but in this is the table showed the effect of parameter from the PID control, but in this research, the parameter only focus on the Kp value only. In conclusion, the objective of the research was achieved as the new control system was implemented in the Arduino software. By using only one parameter from the PID system, which is Kp, the sway angle could be eliminated. But to get the better result on the elimination of the sway angle of the rotational inverted pendulum, the other parameter of the PID must be included in the control system. On the other hand, the original method to collect the data was by having the physical experiment in the laboratory. Due to the COVID-19 cases, the method of research changed to the simulation by using Arduino software. Even though the research was completed by simulation, the practical way to handle the research is by physical laboratory session, as the system can be determined clearly. That's all from me. Thank you.